how to ask the questions in research. More specifically, how to ask them statistically in hypothesis testing. So a quick review. Remember that univariate analysis is a single variable. For continuous variables, you'll summarize with a mean and standard deviation, or a median and IQR, or median and range, depending upon the distribution or the shape of the variable. If it is symmetric, that will be the mean standard deviation. If it is skewed, you'll use the median and either the IQR or the range. If you're looking at categorical variables, you report n in percent for each level of response for that categorical variable. We then move to bivariate analyses, and this is two variables. So the question is, are these two variables related? We have an outcome y and a predictor x. So even if the data is collected at the same time, or cross-sectional data, we designate one of the variables as a predictor and one as an outcome. We can look at contingency table analysis when the predictor is categorical and the outcome is categorical. We can look at group means when the predictor is categorical and the outcome is continuous. And we can look at correlation when both the predictor and outcome are continuous variables. We will use a sample to make estimates about a population. This is called inference. So when we think about our hypotheses, if we want to know if there is a difference in either proportions or means, or if there is a correlation between two continuous variables, we will actually start by assuming there is no difference or there is no relationship. And this does seem a little bit backwards, but we need to set up our scientific or statistical questions in this way so that we can use statistics to choose between our two options. So let's look a little bit more closely at our null hypothesis. This is our default stance or our default situation. Null meaning without value, effect, consequence, or significance. And significance is going to come into play here when we talk about statistical significance. In statistics, our null means that there is no relationship between our x and our y, no correlation, no difference in our proportions, or no difference in our means. Or that is, the difference is zero, or the difference is not, or the correlation is zero, or the correlation is not. And therefore, we call our default hypothesis the null hypothesis H naught. When thinking about comparing our null hypothesis to its equal and opposite alternative hypothesis, so they are mutually exclusive, our null hypothesis is what we currently assume to be true. Our alternative hypothesis is actually, as a researcher, what we'd like to show. We want to show that there's a relationship, or actually see if there is one. Our null hypothesis states that x and y are not related. Our alternative states that x and y are related. Our null hypothesis states that x does not predict y. Our alternative states that x does predict y. Our null says there is no difference in proportions, where the alternative says there is a difference in proportions. Our null would say there is no difference in means by group. Our alternative would say there is a difference in means by group. Our null hypothesis would say there's no relationship or no correlation. And our alternative hypothesis would say there is a relationship or there is a correlation between these variables. Remember, we start by assuming that there is no relationship, there is no difference. This is our status quo. If we switch to believing that the alternative is correct, that we do have a relationship, then think about all the things that have to change. Very simply or very straightforwardly, you'd have to change your belief in the form of this relationship. But often these changes result in monetary changes. So very simply thinking about a clinical trial. If we say that there is a difference between drug A and drug B is better, we then have to get that approved by insurance companies to cover drug B. That means laws may need to be changed, or FDA labels may need to be changed. There will certainly be marketing that needs to be changed, and then we need to get insurance to cover it, and then we need to get doctors to prescribe it. So there are fiscal ramifications, to say nothing of time and involvement in changing to the alternative hypothesis. So we really need to make sure that we are correct and that we've chosen the alternative correctly. Therefore, we'll start by assuming that the null hypothesis is true, that there is no relationship. So we are then going to go through a hypothesis testing process. The first step, again, state your question. So we have a research question. I think that drug A and drug B have different results on blood pressure, but I need to put that into my null and alternative. That means I need to state the null as there is no difference in blood pressure between drug A and drug B, and my alternative would say that there is a difference in blood pressure between drug A and drug B. Then we need to summarize the data that we have and run our analysis. Summarizing the data means looking at our sample. What people are in the sample? What is their age? What is their race? What is their gender? What is their starting blood pressure? How many blood pressure medications have they been on in the past? How long have they had high blood pressure? Then we'll run the analysis on our bivariate analysis, and we will look at those who took drug A and those who took drug B and see if they have different blood pressure measures after taking the medication. That would be a group means if we looked at the continuous measure for blood pressure. It could also be a contingency table analysis if we looked at whether or not people have high blood pressure versus low blood pressure in each of the two drug groups. From there, what's new is we'll determine a p-value, and we'll have more on this later. The p-value is a number or a statistic that will help us choose between our null and alternative hypotheses. After we have gotten our p-value, we will use it to make a decision between HO and HA, or H naught or HA, or our null and our alternative hypotheses. We will then summarize the result. We'll talk about what the sample is, we'll state the question, we'll give our decision, and we'll say what that means. So what is this p-value? P-value actually stands for probability value. And this is not the probability that's associated with our contingency tables, though it is very similar in nature. Very basically, the p-value is how we choose between the null and alternative hypothesis. So we've set up our null to say there is no difference or no relationship, and our alternative says that there is a difference or there is a relationship. So we'll use the p-value to make this choice. We start by assuming that the null is true. We assume there is no relationship or no correlation. We will use data to estimate the relationship, either get the percent by each group, the means by each group, or the correlation measure. We want to know if what we observe from our data, is more likely to be the null of no relationship or the alternative of a relationship. So how do we make that choice? We're choosing between the null and the alternative, and we want to know which is more likely given the data that we have. The p-value is the probability of seeing the results that we saw from our data if the null is true. So remember, we're assuming that the null is true. We assume there's no relationship. The p-value is going to actually tell us what's the probability with the data that we have that what we've seen is unusual. Or do we fully expect to have seen this, that there is no relationship? Our probability will range from very small, that our p-value is very little, we have very low probability of H naught. It can also range all the way up to very large, meaning that there's very high probability of being H naught. So think about this again. A small p-value tells us that we have a low probability that our data resides within the null hypothesis. That means it resides within the alternative. So small p-values will lead us towards choosing the alternative. A small p-value means that the null hypothesis is actually unlikely given our data. Conversely, a large p-value tells us that our null hypothesis has a high probability given our data. So how do we choose? We need some kind of benchmark level. So what's large and what's small? Remember, a high probability or large p-value means that the relationship we see in our sample is likely due to just random chance and we're more likely to stick with the null hypothesis. Low probability, or a small p-value, means the relationship we see in our sample is evidence of a probable relationship in the population. Remember, a relationship in the data is the alternative hypothesis. So how large is large and how small is small? This is where something very critical to statistical testing comes in called alpha. Alpha is what we compare our p-value to. We generally set alpha at 0.05, and if our p-value is greater than 0.05, then we'll stay with the null hypothesis of no relationship, no difference. If our p-value is less than or equal to 0.05, then we'll choose the alternative and say that we do have evidence of a difference or relationship. So you may ask, why 0.05? Well, 0.05 is 1 out of every 20. So if you ran this experiment 20 times, we would be comfortable one of those 20 times choosing the alternative incorrectly. So remember, we assume the null hypothesis is true. We can be right and pick the null, and we can be wrong and pick the alternative. Alpha is actually how often we're okay with being wrong by picking the alternative when the null really is true. So alpha is how often we are willing to be wrong in that direction. 5% of the time, we're okay picking the alternative when really there is no relationship and the null is true. Of course, we never really know whether it's the null or the alternative that's true. And the reason that we don't know that is that we cannot collect data on the entire population. We are using a sample. So what do you say when you run statistical hypothesis testing? If the p-value is greater than 0.05 and you pick the null hypothesis, there's a very statistical way to say we failed to reject the null hypothesis. So we assumed the null and now we're failing to reject it, or we're concluding that we have no relationship. There is no difference in the proportion or means, or there's no correlation, or there is no significant difference or correlation. If the p-value is less than or equal to alpha, and we pick the alternative hypothesis, we can say we reject the null hypothesis. Again, this is a very statistical way to say that, and more commonly you'll actually make the statement that there is a difference in the proportion, or there is a difference in the means, or there is a correlation. Another common phrase you'll hear is that there is a statistically significant difference or a statistically significant correlation. So what about things that we never say? You never, 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 never say we have proved either hypotheses. What you have done is shown or concluded there is evidence of a difference or correlation. So just keep those words in mind. Precision is very important in statistics, and we don't want to say things that we can't actually stand behind. In this activity, using the CombiRx infection data from the midterm review, fill each of the questions out. Use your fit y by x and fill in the blanks in the sentences on the practice exercise. You will need to define the null and alternative hypotheses from a simple research question. You'll need to fit y by x and find the p-value. And then you'll need to make a conclusion about which hypotheses you're going with, and what is the conclusion in words. You need to use the notes from this section to find out where to get the p-values for each of the fit y by x options and how to interpret them.